this should be borne in mind. Let us look at one more problem, problem number 16. This is a tricky problem. What is asked is something like this is used as a weighing balance. Okay. We have, let us say, the item over here and the weight over here, and we want to use this as a weighing balance. Okay. What is asked is, let me just read it out for you. It consists of a rod hung from a hinged link. There is a hinge over here and there are two pans on each side of it. Okay. The question is, what is the mistake with this kind of design? That is the question. Okay. Now, it looks that there is no problem at all. Let us say if I have a weight over here, let us say this offers a W, this will also offer a W, okay, if I have a balance, right. Let us draw the free body and check whether there is any mistake at all. So, let us draw the free body of this scale. Okay. Remember, the choice is the scale. Let us say this is hung like this just for now, and therefore, when I remove this, it will offer a horizontal and a vertical resistance. And if you notice carefully, though this particular hook offers resistance in the x and y direction if held tight, this in itself does not give that much of resistance in the horizontal direction, and therefore, this force here is a negligible force. What are the other forces? This is due to F due to the item, and let us say this is F due to the weight. This is the reaction from the wall. This is what we have. This length is L and this length is L. Okay. And if I have to consider the weight of this also, I will insert a weight over here. If this has to be used as a weighing balance, how do we use a weighing balance? If this balance tilts in this direction, it means that the item here should be heavier than this, and if it tilts this way, item is lighter than the weight that I put, right. If you look at it carefully and take moment about this particular point, sigma, let us say I am going to take this as positive, all the moment about this, let me call this as O, this is A, this is B, moment about O is equal to 0 implies F item, okay, times this lever arm which is L acting in the clockwise direction, so that this is minus, plus similarly for the other one which is F weight times L. This should be equal to 0 according to this free body. What is happening here is Ln and cancel off. So, I should have Fw equals F item for equilibrium to happen. Now, the question is, what if F item is greater than Fw? If F item is greater than Fw, it will start to rotate like this. Will this rotation stop? The answer is no. In this particular case, the rotation will not stop, because when it rotates, it will rotate about this like this. These 2 points will always be equidistant from this, and therefore, rotation will continue to occur till it reaches this position, and therefore, this cannot qualify to be a design for weighing balance. What should I do? Supposing I fixed this to the scale, then it qualifies to be a weighing balance. That is not very difficult to understand, because now this is the point that I can take as the interaction point. So, let me just draw that free body. This is the point. As you can see that this hook does not rotate with respect to this scale, and therefore, it should be rotating like this. If this point is over here, let us call this as O, you can notice even though these lengths are the same, this length, I am sorry, this length and this length, this lever arm and this lever arm are now different, and therefore, what should happen is, if this weight were more, it will try to tilt in such a way that this lever arm comes down to a degree that F item times that length balances F weight times the other length, and therefore, I will see a rotation with respect to horizontal, and that will tell me that this weight item is heavier than the other. If the weight is heavier than the item, then it will rotate in the other direction. Okay. This is a common mistake that we observe in some of the designs.